afternoon, everybody. I'm glad to see you and really want to start working with you. I wish you good mood and good luck. Sit down, please. What day is it today?
The 20th of December.
Look at the board. Listen carefully.
If I ask you what is the similarity between a sugar grain and a diamond, maybe you'll say that they both are lustrous. And what if I ask you the similarity between a diamond and a graphite? A graphite is just this piece of black stone used in laboratories. Maybe you'll think there is no similarity. Is there really no similarity between these two? The answer would surprise you. There is something common between all these three things. I'm referring to the element that these three are made up of. I'm referring to carbon. Wait a second. Are we saying that the sugar, the radiant diamond, and graphite are all made up of carbon? Absolutely. In fact, diamond and graphite are almost pure forms of carbon. They are majorly made up of carbon with a few minuscule elements that come as impurities. But how can there be so much difference in the looks of different materials made up of the same element? How can it be possible that the substances made up of the same element, carbon, appear totally different? And wait, they also have different chemical properties. The looks are different, the chemical properties are different, but they're made up of the same element, carbon. Is this some kind of magic? Well, the magic lies in the element itself. The element carbon has several interesting properties, and that's what makes it special. It is capable of forming bonds with most of the elements. That is the reason why carbon compounds are quite commonly found everywhere. But did you know that carbon is actually present in very small quantities in the Earth's crust and also in the atmosphere? That's the irony. In spite of being present in almost every compound around us, carbon accounts for almost less than 1% in the Earth's crust and the atmosphere. But have you ever wondered what makes carbon so unique? What gives carbon the capability to have so many different properties? Let me give you a hint. Can you tell me what are the chemical properties of elements based on? Yes, they are mainly based on the atomic number. The atomic number is the number of protons in the atom. And why is it so? Because the number of protons in an atom is equal to the number of electrons in it. Right? And electrons, valence electrons to be precise, are the ones that participate in chemical reactions. So is number of electrons in the outermost orbital our answer? Absolutely. The chemical properties of an element are based on the number of electrons present in its outermost orbit. We know that the atomic number of carbon is 6. That means the electronic configuration of carbon is 2, 4. Now let me ask you a question. Look at the atomic structure of the carbon atom. To achieve stability, will carbon take 4 electrons or will it donate 4 electrons? Well, the simplest way to achieve the octet state will be by sharing electrons. This gives us the answer to many queries. Yes, the fact that carbon can share its outermost electrons with any other element gives it the capacity to form chemical bonds with various other elements. Now let's meet in the next video wherein we will learn about the covalent type of bond. Then we will move ahead to learn more about the bond formation seen with carbon.
What is the common between sugar, diamond, and graphite?
Carbon.
What is that?
Carbon.
Carbon. Good. And so what is the topic of our lesson? What is the topic of our lesson?
Carbon.
Carbon. Good. Yes. What is the common between sugar, diamond, and graphite?
Carbon.
Carbon. Yes. And so, what is the topic of our lesson?
Carbon.
Carbon. That's right. The topic
power levels. The external power level contains 4 electrons.
And what is the electron configuration of the atom? Asema? How many protons, neutrons, and electrons? Asian?
6 protons, 6 neutrons, 6 electrons.
Good. Open your copybooks, write the new words. Vocabulary, new words. Carbon, charcoal, diamond, fullerene, adsorption, carbon dioxide, marble, limestone, baking soda. Write the new words. Repeat for me. Carbon, charcoal, diamond, fullerene, adsorption, carbon dioxide, marble, limestone, baking soda. Next. Discover everything. The English name carbon comes from the Latin carbon for coal and charcoal, which also comes the French carbon meaning charcoal. Carbon was discovered in prehistory and was now in the form of wood and charcoal to the earliest human civilization. Diamonds were now probably as early as in China, while carbon in the form of charcoal was made around 1 times by the same chemistry as it today. By heating wood in a ceramic covered with clay would expose air.
Years ago, the Earth was covered in tropical forests that stretched across the vast continents. The Euro-American continent, Northern Africa and China. These vast fertile forests produce so much oxygen that the proportion of oxygen in the atmosphere increased to 35%. It's 20% today. The Earth cooled. As vegetation died in this period, some of it collapsed into gigantic swamps, where it was then covered in water. In water, it did not decay and release its carbon. The carbon was instead trapped in the form of heat. Under pressure over time, that heat turned into coal. Vast carbon stores were locked in underground. Eventually, oxygen stabilised at about 20%. Human chemical. The Aztecs discovered you could burn coal. They used it for fuel. The Chinese made the same discovery. Greeks and Romans used it to forge metal. And then, 1760, the steam engine, the Industrial Revolution, mining, spinning, milling, international travel, warm buildings, electricity. Burning coal and building industries became inextricably linked. Coal meant growth, development and wealth. We dug it up by the time they had a gigaton, built industries around it, communities, and 250 years later, its electricity still powers our cities. And so the carbon, locked up for hundreds of millions of years, was released as carbon dioxide. In 1760, carbon dioxide was 280 parts per million in the atmosphere. Today it's 414 parts per million, a 47% increase. Hold your emotion.
In 1791, the English chemist Tennant was the first to obtain free color. In 1772, the French chemist Antoine Lavoisier showed that when a diamond bursts, carbon dioxide is formed. Exercise. Fill in the table. Exercise. Fill in the table. First formula, resultant.
Calcium carbonate.
Second formula, what?
Sodium carbonate.
Third formula, Batasan,
Sodium hydrocarbonate.
hydrocarbonate. Common name, first. Common name, first. Acid,
Limestone.
limestone. Next,
Washing soda.
washing soda. Next,
Baking
baking soda. Good job. Next, now you will work in groups. Let's divide into four groups. Four groups. First groups, allotrope of carbon. First groups. First groups. First groups.
Milk.
Second groups. Second groups. Second groups. Third groups. Third groups. Third groups. Fourth groups.
physical properties. Presentation of author 3 minutes.
Carbon is one of the most well-known elements in the world. Carbon is the largest member of the group number 14. It's a non-metal. In the group, atomic radius and organic protections increase from top to bottom.
There is a big number of carbon compounds. Carbon is the basic element of living organisms. In our daily life, it is found as petroleum and it's produced for that reason carbon chemistry has become a special branch of chemistry covered for organic chemistry.
Properties: graphite, diamonds, fluorine.
Atomic number 6, sample C, atomic weight 12, element classification non-metal, density 2 and 25.
Hang on a second.
Let's clap first group. Second group, electrophic.
Allotropes of carbon: graphite, non-tube, fluorines, diamond.
Fluorines is allotropes of carbon which have the form of hollow spring, sad, ellipsoid, and many other shapes. Carbon nanotubes of cylindrical fluorines, it have unusual proportion.
Each carbon atom is a diamond. Is covalently bonded to 4 other carbon in a tetrahedron. Properties: diamond is a non-conduction of heat and electricity. Used as gem in jewelry.
For this reason, graphite conducts electricity along the planes of carbon atoms, but it does not conduct electricity in a direction at each angles to the plane.
Let's clap second group.
Carbon is non-metal. It has an atomic number over 6. It takes oxidation states between -4 and +4. Carbon is reactive in phases with increasing temperature. Chemically, carbon is inert under normal conditions. Carbon reacts with hydrogen to produce methane. Carbon reacts with oxygen to produce carbon dioxide. Carbon reacts with nitrogen to produce cyanogen. Carbon reacts with fluorine to produce the fluorine methane. Carbon reacts with water to produce carbon dioxide and hydrogen. Carbon reacts with tungsten to produce tungsten pellet. With oxide, wood reacts with the carbon to produce wood and carbon dioxide. And finally, carbon reacts with nitric acid to produce carbon dioxide, oxide, and water.
Let's clap. Next group.
Types of carbon. Carbon has 2 oxides, carbon monoxide and carbon dioxide. Carbon monoxide and carbon dioxide and colorless odor.
Carbon monoxide is found in the atmosphere in trace amounts. Carbon dioxide is produced when limestone is heated to make QE.
Carbon dioxide with water produce carbonic acid.
Carbon dioxide reacted with carbon
Calcium oxide.
calcium oxide.
Produce calcium carbonate.
To produce calcium carbonate.
Carbonate.
Calcium carbonate.
Carbonate. Let's clap. Test questions.
Сделаю.
You have a sticker on your desk. Let's know how our lesson went. The lesson is over. Goodbye.
Goodbye.